Hey guys, welcome back. Today we're going to talk about electrical energy. Okay, that's energy with the flow of electrons. So, electrical energy can be very helpful for us. It turns on our appliances, it gives us energy to maybe turn on some lights, to turn on the heater at your home. You know, it has a lot of great things for us. Now, how does electrical energy work? Okay, so electrical energy has to be run in circuits. Okay, so today we're going to build a couple of circuits, and I want you to see the difference between the circuits that I built. Okay, so the first circuit that I want to build is going to be a battery. This is a 9 volt. Again, you do have to be extremely careful with batteries, so please don't try this at home. Okay. Okay. Also, if you have insulation clamps, that would be great. Okay, that way it prevents the metal part to touch the other metal part. You don't want them to touch because then it will eventually heat up. Okay, and then we don't want that. So, okay, that's called a short circuit. Whenever we connect these two together, the electricity flows in this position over and over and over and over again, and eventually heats up. Okay, and that's something that we don't want. Okay, so just please do not try this at home. This is only for observation purposes, guys. I cannot stress this enough. Okay, please don't try this at home. Just observe and watch. Okay. All right. So what we're gonna do, like I said, is we're gonna create a circuit. In this case, I'm going to use Christmas lights since Christmas is always fun. Okay, I have 3 different Christmas lights. Okay, so let's turn them on. In order for this light to turn on, okay, I have to connect to the wires. Okay, so as you can see, I have 2. So if I connect one wire on there, okay, as you can see, it does not turn on. Why does it not turn on? What do I need? Okay, so basically I need to close the circuit. Okay, I need to close the circuit. When I close the circuit, voila, okay, the light turns on. That's because electricity from the battery is transferred through the wires. Electrons are traveling through. They go up the light bulb, down the light bulb, through the wire, all the way across to the other side. Now, let's look at what the wire consists of. Okay? So if you look closely, okay, there is a metal part here. This metal part is basically attached so that it can conduct the electricity. The wire inside is made out of copper. It's traveling through inside the insulated wire. So the green part is actually a piece of plastic that prevents the electricity from, escaping. So it kind of stays inside, insulated, so that when you touch it, you don't get hurt. So it gets insulated, and then once it leaves the outside, it is a conductor again. So it conducts the electricity like so. So I connect it to the metal part, because let's say I want to connect it to the green part. What happens? It does not turn on. Okay. If I connect it to the green section, it does not turn on. So let me turn it on, the metal part, and that is a conductor. So it does turn on. So it allows the energy to go through. Okay. Let's talk a little bit about this circuit. Okay. So you do need a battery, and the battery does have a positive and it has a negative side. Okay. In order for this to work, you have to have the positive and the negative side. So usually the black wire is the negative. So the negative allows the electrons to travel through the wire. And then the positive side is where it ends. Okay. So it goes negative to positive, negative to positive, negative to positive, over and over and over again. And that's why the light stays on. As soon as I cut the circuit, as soon as I open the circuit, notice that it immediately turns off the electricity. It's kind of like a bridge. When you're going to cross a bridge, whenever a bridge, this is a little bit more of an older times. When the bridge opens so that maybe a boat can pass by, the bridge opens, okay? The cars behind it have to stop. Same thing, the electricity, whenever the bridge opens, the electricity stops from going. But once the bridge is closed, traffic continues to travel from one side to the other, okay? It's the same thing, okay? This is just an example. All right, this circuit right here, this circuit is called a closed circuit because it is closed. When I remove the wire, it's called an open circuit because there's an open section right here, okay? Open circuit. Closed circuit. All right, next, it's also called a series circuit, okay? The reason why it's called a series circuit is because there's only one path that travels through, okay? That means that it's only one path, so if I cut that path's way, it turns off. Now, at home, you may have a series circuit. Whenever you go to your room and you flick the lights on, okay, it turns on. That's a series circuit. When you flick it off, it turns off, and it is a closed circuit, okay? All right, now sometimes at school, when you turn on one of the switch, it turns half of the lights on, and then when you there's multiple switches in your classroom. So when you turn on the other switch, it turns on the light from the other side, okay? And this is called a parallel circuit, okay? It has more than one path. So right now we have one path, and we're gonna create a second path by adding, okay, another section here. When I connect it here, I'm gonna add one more, okay? And notice that I am creating a second, let me put it sideways. I am creating a second path as so. So the battery, okay, this is one path, and I'm gonna create a second path, okay, by adding another wire. Now, can everybody see? Can you guys see the second path? Notice that the light still is on, still stays on, okay? You see it? Okay, the light stays on, both of them turn on, okay? So now I have a parallel circuit, kind of like parallel lines, okay? A parallel circuit. That means that this circuit right here is working, and then this circuit over here is working. But if I remove the wire from this circuit, do you think this light bulb will turn off? It's actually on. It's kind of hard to see, but the light bulb is on. Here, let me turn off the light so we can see this. As you can see, the light bulbs are on. Okay. Okay. So when the light bulbs are on, and you can barely see it still. Okay. But you can see this one's on. They're both on. So when, there we go, it's a little bit brighter. So it's brighter because guess what? It disconnected from here. When it disconnects, this one becomes a little bit brighter. But guess what? This one stays on. As soon as I plug the other one in, this one stays on and that one stays on. Okay. Now, how can I disconnect? How can I turn this one off but keep this one on? Very good. I have to disconnect it from here. So when I disconnect it from here, it turns off the middle one, but I keep the second one on. Notice that there is two paths. This is one path, and then this is another path all the way over here. Okay. All right. That's a parallel circuit. If I wanted to do a series circuit with this one, I'm going to remove some of the wires and I'm going to connect it in a different way. Okay. Let me remove this one and let me connect it like this. All right, so now notice that it is connected in one circuit. Even though I have two light bulbs, there is only one circuit, one path. Okay, this right here is a series circuit. Okay, it's only one path. The electricity goes in one direction. It doesn't have another way to go. So if I was to turn this one off, what do you think is going to happen? Oh, sorry, I went ahead. If I turn this one off, it turns off the other one. Why? Because you basically create a gap. When you create a gap, the light does not have electricity to turn on. Now, if I want to turn this one off, I would have to disconnect it from here. But guess what? It also disconnects and turns off the other one. And this is what a series circuit does. When you turn one light off, they all turn off. In a parallel circuit, when you turn one of them off, the other one could stay on, okay? And that's what we saw on the other different one, okay? All right, guys, so hopefully you got the gist of this lesson. It's basically, let me go ahead and go over it again, and then we'll conclude. So we have a battery, and again, a battery has a positive and a negative, okay? Just like a magnet has a north and a south, batteries have positive and negative. The negative energy, or the electrons, travel through turning on the light. It goes around the opposite side, and then it goes back into the battery, and then it continues the flow. So it's a constant flow of energy. It's a constant move of electrons, okay? As soon as I create a gap, one of the light bulbs turn off, I'm sorry. As soon as I create a gap, there's a gap right here. So the light bulb turns off. As soon as I close the gap, the light turns back on, okay? This is called a complete circuit because the light is on. It is a complete circuit. When I disconnect one, it is called an incomplete circuit because it is not complete. It's not completed. There is a gap. There's a space in between, okay? All right, guys, so this is the simplest I can go. I will go ahead and make it a little bit more complicated the next time we see you guys, okay? So right now we're gonna stick to the basics and learn about what is a circuit, what is the purpose of it, and then how can a series circuit be different than a parallel circuit, okay? Parallel circuit being the more complex circuit, and I'll give you more examples next time. All right, guys, thank you so much for watching. You have a great day.